Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, in today's class we are going to continue the chapter electricity, and this is 8th period of this chapter. And yesterday we focused on two important concepts. Can you recall them? What are these? Yes, the very first one was we solved many problems on series connection, parallel connection and mixed connection. And also we learnt how to find out the sum of the physical quantities like electric current and potential difference using the circuit diagrams in which resistors were connected in different ways. And the second important concept was when the electric current flows through the conductor, heat is produced, right? What do you call that? Yes, it is heating effect of electric current. Can you recall the definition of heating effect of electric current? Yes, recall with me. When an electric current flows through a conductor having some electric resistance, then heat is produced in that. This is known as heating effect of electric current, right? Then how heat is produced? Yes, heat is produced due to the friction between electrons and the atoms present in the conductor. Electrons and inner walls of the conductor, friction between electrons with other electrons, right? And we have come across many devices which work on heating effects of electric current. Now, in today's class, do you know what we are going to learn? If you have gone through the NCERT textbook, you are able to guess. We have already come to know that when the electric current flows through the conductor, heat is generated. Is it possible for us to calculate what amount of heat is generated in the circuit? Yes, this is possible by using the formula. In today's class, we are going to derive the formula to calculate the heat produced in the conductor having some electric resistance. Now, let's go for derivation. Observe this. I have written the question. Derive the formula to calculate the heat produced when electric current flows through a resistance wire. Resistance wire is much needed because if heat has to be generated, there must be obstruction for the flow of electrons. This is possible from resistor. So now I am considering some of the physical quantities. The first one is R. What is R? It is a resistance of a resistor wire. Resistance of a resistor wire. Then only just by wire only it is not possible to produce the heat. It should be connected to terminals of a battery, where battery is the source of EMF, which maintains the potential difference. So I'll take V. V represents voltage of a battery or potential difference between the ends of a conductor. Voltage of the battery. Then when the free ends of the conductor are connected to terminals of a battery, then the charge particles start moving, right? I take Q is quantity of charge. Quantity of charge. When the charge particles start to move in a particular direction, then we say that current is constituted in that circuit, right? So I go for taking I. What is I? It is current flowing through a resistor. Flowing through a resistor. Then obviously heat is generated. But amount of heat generated depends on how long the current flows in the circuit. Hence I take T. What is T? It is time for which current flows. Current flows. Okay. Now let's go for deriving the equation. For derivation, I'll go for using some other equations or some other formula what we have discussed in the previous periods. Here, if the current has to flow, that is the charged particles have to move, then work has to be done. So how do you represent the work done in moving the charged particles? Yes, here I write. We know that work done in moving the charge Q through a resistor is given by, yes, how do you write that? Given by, it is W is equal to V into Q. Do you accept this? Yes. How? It is because we all know that voltage is equal to W by Q and W is equal to V into Q. I call this as equation 1. Then we need to take substitution for both V and Q. Here I go for writing. When the electrons start moving, then we say that the current is constituted. Can you tell what amount of current is flowing in the entire circuit? This can be given by a formula. What is that? I equal to Q by T. Here I write. We know that current flowing through the resistor is given by, it is, how do you write? I is equal to Q by T. We need to take substitution for Q. Hence, let us solve Q. Q is equal to I into T. Call it as equation 2. Understood? Then when the current is flowing in the circuit, there is a relationship between current and the potential difference between the ends of a conductor. That relationship can be expressed by, what is that? Ohm's law. Yes. According to Ohm's law, by Ohm's law, how do you write? It is R is equal to V by I. But what is needed? V. Then V is equal to I into R. I call this as equation 3. So we have got both the terms V and Q. Let's go for substituting 2 and 3 in 1. Here I write. Substitute equations 2 and 3 in equation 1. Then W is equal to V into Q. What is V? V is I into R. Q. What is Q? It is I into T. It is equal to I square into R into T. W equal to I square into R into T. What is W? W is work done. Why? That means work was done to convert electrical energy into heat energy. Then can we write work done is equal to heat energy? Yes. Here I write. Work done. Work has been done to produce heat. So I write heat energy. That means in place of W, I can go for taking H. Now we can rewrite this equation as H is equal to I square into R into T. So this is the formula used to find out heat produced when electric current flows through a resistor. Do remember, H is equal to I square into R into T. Understood? And this is known as Joule's law of heating, not just formula. We are going to make a statement using this formula. And we call that statement as Joule's law of heating. Now I will give you that statement. Before that, I have to give you 2 more important points. That is, the heat is produced in the conductor and it is also measured. As it is to be measured in terms of which unit? That means what is the SI unit of heat energy? Yes, you are right. It is Joule. SI unit of heat energy is joule. Now, can we rewrite this formula? The reason is, look here, H is equal to I square into R into T. Then I go for writing I square as I into I, then IR into I into T. What is I into T? Use this formula. Current formula, I equal to Q by T. Then I into T is Q. Now we can write it is IRQ. Got it? Because I is equal to Q by T. This is another formula. That means you can find out the amount of heat generated in the circuit when you know the amount of current flowing and quantity of charge as well as the electric resistance of that element. Yes. Now I'll go for explaining the further part of this chapter, this concept. Before that, you have to pause the video and should copy from here to there. Please, when you are writing, please go on understanding every step. Yes, copy this. Just we have derived the formula to find out heat generated in the circuit. Right? That is, what is that? It is H is equal to I square into R into T. The heat generated depends on the amount of electric current flows, then electric resistance, then time for which the current flows. Then how does heat generated depend on these physical quantities? Just look here. Here, what happens, that is, what will be the heat generated in the circuit as the amount of current flows in the circuit increases. As current increases, there will be oftenly the electrons will come across the friction. So due to this, more amount of heat is generated. Right? So now we can write as current increases, heat also increases. As the amount of current decreases, the heat generated also decreases. Right? Then how they are related? Heat generated is directly proportional to the current flowing in the circuit. Clear? Next. And here square is there. I will go for writing square. I will tell you later why. Next, another one is R. As the electric resistance increases, what happens? When the electric resistance increases, there will be more obstruction, due to which more friction takes place. As a result of it, more amount of heat is produced. Therefore, we can write as electric resistance increases, heat generated also increases. As it decreases, heat generated decreases. So H is directly proportional to R. Next, time. How heat generated is related to time. As the time for which the current flows in the circuit increases, obviously heat generated also increases. As it decreases, heat generated also decreases. Then we can write H is directly proportional to T. Now observe. Here, the amount of heat generated is directly proportional to square of the current, directly proportional to resistance of the resistor, directly proportional to time for which current flows. And this statement is known as Joule's law of heating. What it is? Joule's law of heating. Then what is the statement of that? Very simple. If you know the formula, easily you can go for making the statement. When an electric current flows through the conductor, what happens? The heat is generated, and this heat energy is directly proportional to square of the current flowing in the resistor. Then directly proportional to resistance of the resistor. Then another one, time for which electric current flows. Now I am going to make a I'm going to write the statement. You should also write with me. Okay. In note only, you can go for making this as the third point. That is how heat energy produced related to these three physical quantities: current, resistance, and time. I have written all these. All are directly proportional. Okay. And now based on this, we have written the Joule's law of heating. It is very important in the examination point of view. Can be given. Just before last year only it was asked. According to this, we can write the statement in this way. When an electric current flows through a conductor having resistance, then heat is produced. So this heat energy is directly proportional to first one. See the square of the current for a given resistor. And second one, the resistance for a given current. And third one is the time for which current flows through the resistor. You have to write like this. Clear? Simple way. The heat produced, that is Joule's law of heating states that the heat produced in the resistance wire is directly proportional to square of the current, directly proportional to resistance of the conductor, and directly proportional to time for which current flows. You can also write in this way. Now observe. I'll give you time for writing, just keep observing this. Here I'm going to take the formula again. H is equal to I square into R into T. Now we will come to know how the heat generated increases or decreases as these three physical quantities increase or decrease. Suppose I'll take the current. We know that heat energy is directly proportional to square of the current. Suppose current is doubled. When it is doubled, then it will be 2 whole square. 2 square is 4. Then amount of heat produced increases by 4 times. Clear? For some amount of electric current, for example, just 2 amps of electric current, assume that 1000 joules of heat energy is released. If it is doubled, that is, when it is doubled, 2 amps means 4 amps. When it is doubled, then amount of heat energy produced will increase by 4 times. 1000 becomes, it is 4000 joules. Clear? Next, when it is tripled, the current amount of current flowing in the circuit is increased by 3 times. Then 3 square equal to 9. So heat energy produced increases by 9 times. Got it? Suppose current is reduced to half. If 10 amps of electric current is flowing, we are going to reduce that to 5 amps of electric current, like that. If it is reduced to half, then 1 by 2 whole square, it is 1 by 4. Heat energy decreases by, amount of heat energy produced decreases by 4 times. Understood? Okay. Next, second one. We know that H is directly proportional to R. When the resistance is doubled, when it is doubled, even it also increases by 2 times. When it is tripled, resistance is tripled, amount of heat energy increases by 3 times. When it is reduced to half, it is also reduced by half. In the same way, T, as time, we know that heat energy is directly proportional to time. It is when time is doubled. Suppose we allow the current to flow through in the circuit for about 5 minutes. If it is doubled, that is 10 minutes. In such case, the amount of heat energy produced also increases by 2 times. If it is tripled, it is also increases by 3 times. If time is reduced to half, the heat generated reduced by half. Clear? Next, another important question. Suppose current is doubled, then resistance is also increased by 2 times. Time increases by 2 times. Then what is about the amount of heat energy? How many times? When these terms increases, then obviously heat energy also increases. Then by how many times? Here you can write, see, 2I whole square. 2 square is 4I square. Then this is 2R. This is 2T. 4 2s are 8. 8 2s are 16. I square into R into T. Observe it. Heat energy increases by 16 times. Followed? Okay. This type problem can be asked in the examination. You have to focus on this. Now, you are going to write the statement of Joule's law of heating from here to here. Copy this. Now, let's focus on some of the important numerical problems on Joule's law of heating. That is the formula H is equal to I square into R into T. Go through the first one. Please don't go for copy. Observe. An electric iron 20 ohm takes a current of 5 amps. Calculate the heat developed in 30 seconds. Dear students, I have already told you many times, in case of numerical problems, first you have to identify the given information. An electric iron 20 ohm. What does 20 ohm indicates? It is resistance. R is equal to 20 ohm. Takes a current of 5 amps. 5 amps is current. I equal to 5 amps. Calculate the heat developed in 30 seconds. T is equal to 30 seconds. Even the time can be given in terms of minute also, hours also. Under such condition, you have to convert that into SI unit. That is seconds. T equal to 30 seconds. Then you are going to find out H. We have a formula to find out heat generated. That is H is equal to I square into R into T. What is I? It is 5 whole square into R. It is 20 into T. It is 30 seconds. This is equal to, what is 5 square? 5 square is 25. 20 into 30, 2 3s are 6 and 2 zeros. It is equal to, now 25 6 are 150 and 2 zeros. So 15,000 joules. The amount of heat developed, heat generated in the circuit is 15,000 joules. You can also write it as 15 K. That is 15 kilo. Or you can write 1.5 into 10 raised to the power 4 joules. Understood? Okay. Now come to second one. Compute the heat generated while transferring 96,000 coulomb of charge in 1 hour through a potential difference of 50 volt. Then how do you go for finding it out? Observe. Here you are going to find out the heat generated. To find out that, first let's go for writing the given information. While transferring 96,000 coulomb. 96,000 coulomb, it is quantity of charge. Q is equal to 96,000 coulomb. In 1 hour, T is equal to 1 hour. It is equal to 3,600 seconds. Through a potential difference of 50 volt. V equal to 50 volts. Let's go for finding H. We have the formula, that is H is equal to I square into R into T. Observe. I, it is not there. R is not there. Then time is given. Then how do you go for calculating it? Observe it. Here we can give the relationship for IR and I into T. Right? I am going to grouping them. So we need to recall the previous formula. What are those? Look here. R is equal to V by I. It is according to Ohm's law. Then V is equal to I into R. So in place of IR, I can write V. Then I into T. We all know that I is equal to Q by T. Then cross multiply. Q is equal to I into T. So in place of IT, you can write Q. See that? We know voltage as well as charge. You can write this is equal to voltage is 50 into that is 96,000. It is equal to how many times? Zeros are there? 4 times. Now 96, 5s are. 96 times are 960. Sorry, 96 times are 960 and 5s are half of 960. It is 480. Or else you can write 5 6 are 30. 3 is the carry. 5 9s are 45 plus 3 48. It is 48 lakh joules. This much amount of heat energy is released. Clear? Now we have one more type of problem. Observe this one. Here also first let us go for writing data. Before that, let's go through the given statement. A resistance of 40 ohm is connected to 20 volt battery. Calculate the heat energy generated in terms of joules. Then current, the time is given, it is per minute, that is 1 minute. Let's go further. Writing the data. Resistance of 40 ohm, R equal to 40 ohm, is connected to 20 volt battery, voltage 20 volts. Then time is given, it is 1 minute. It is nothing but 60 seconds. You are going to find out H. Calculation. We have the formula to find out H. H is equal to I square into R into T. Then we have R. I and T are. T is known, but we do not know I. How do you go for writing? Finding I. R and V are given. So you can find out I by using Ohm's law. How do you write according to Ohm's law? Yes, it is R is equal to V by I. Then I is equal to V by R. What is V? It is 20 volts. R 40 ohm. It is equal to 1 by 2 amps. This is current. Here only I will write. It is I is equal to 1 by 2 amps is nothing but 0.5 amps. Let's go for using the formula. H is equal to I square into R into T. What is I? It is half. Half whole square into R. R is 40. What about the time? Time is 60 seconds. This is equal to, now 1 by 4 means square should be applicable to both numerator and denominator, into 40 into 60. You can cancel 4 ones are 4 tens are. Now 60 tens are 600. 600 joules. Did you understand? So all the three problems are important one, and the first two, these have been taken from NCERT text, and this is just additional from old question paper. Understood? And now you have to pause the video and you should copy all the three problems from here to here. Just copy this. Now we have another important question. It is fourth one. Just go through this. 100 joule of heat is produced in each second in 4 ohm resistance. Find the potential difference across the resistor. Let's go for discussing that later. Before that, first let us write the data. See, 100 joule of heat is produced. Heat produced is already given. How much it is? It is 100 joules. In each second, that is in every second, alright, T is equal to 1 second. In 4 ohm resistance, R equal to 4 ohm. You are going to find out potential difference. Now, observe it. You are going to find out potential difference. We have the formula to find out heat produced, that is H is equal to I square into R into T. But how do you find out V? If you know the volt, if you want to find out the voltage, you have to find out the current, because there is a relationship between current and voltage. Hence, let us find out the current by using the formula H is equal to I square into R. I square into R. R into T. Observe. We want I, hence I solve I square. I square is equal to H into H whole divided by R into T. Then I is equal to square root of H by R into T. Then go for taking substitution. Square root of what is H? It is 100 by R. It is 4 into time 1 second. It's equal to square root of, cancel it, 4 ones are 425. Square root of 25 is 5. It is 5 amps. Current is 5 amps. Then how do you go for finding the voltage? To find out the voltage, we have the formula, that is according to Ohm's law. We can write R is equal to V by I. We want voltage. Voltage is equal to I into R. As we know, current as well as resistance, you can find out the voltage. What is I? It is 5 amps, and R 4 ohm. It is equal to 20. So V equal to 20 volts. So potential difference across the resistor is 20 volts. Did you understand? Okay, so these are the important numerical problems. Now we are moving to some of the important applications of heating effect of electric current. Dear students, you all know that whenever the electric current flows through the conductor, heat is generated in that, and the amount of heat generated depends on the resistance of that circuit and some other factors like time as well as the amount of current also. Is it not? Then when the current flows, whether it uses all the amount of current to convert that into heat energy? No. The maximum amount of current is used, and the remaining current will be used for converting again heat energy into some other form of energy. Now with this information, let's go for applications of heating effect of electric current. So before that, you just go for copying this one. Just copy from there to here. Observe. Practical applications of heating effects of electric current. Dear students, I told you, when electric current flows through the conductor or a component, generating heat, it is quite common. It is inevitable because every component and most of the conductors will offer electric resistance. Therefore, heat is generated. That means electrical energy is converted into heat energy. Then obviously, when the current flows, then the components, the temperature of the components will increase. Even it may alter the some of the properties as well. In spite of all this heating effect of electric current has some important applications. Example, you go for taking an electric iron box. See that here it works on heating effect of electric current. Here heat is much needed. You may go for taking one of the component that we use in our house, which converts electrical energy into heat energy, then light energy. Can you tell what it is? Yes, you are right. It is an electric bulb. And one more, in our house, in the meter box only, one device will be installed which protects from the electric shocks and all. When the excess amount of electric current flows in the circuit, automatically it breaks the circuit. What is that safety device? It is fuse. Like that, many are there, but in this chapter we are going to focus on two important electrical components which work on heating effect of electric current. They are, one is electric bulb and second one is electric fuse. Here I'll write that. The first one is electric bulb. Then what is electric bulb? We know that it is a device which converts electrical energy into heat energy, then light energy. You might have seen that its construction also, right? In that there will be a filament. It holds large amount of heat. What is that filament? It is tungsten. Then with that much amount of heat is produced, in spite of that the bulb does not burst. Why? It is because the bulb is filled with and chemically inactive gases like nitrogen or argon. So these will protect the bulb from bursting, or these gases will give long life to the electric bulb. Just I am going to draw that. Observe here. Just keep observing the way I am going to draw. It is a cap that you can see, silver cap it is. Now you can see that there will be 2 points. These 2 points are called terminals. And here you can also observe there will be pins, because this bulb is to be fixed in the holder. For that support there will be 2 pins. And this is an electric bulb. Observe. Here also there will be one part, you might have observed that, which is made of glass, which is called the stud, nothing but support. For what? Here there will be 2 wires. You might have observed that these 2 wires are copper wires, and from here also 2 more wires will be there. Then here a spiral like wire will be there, and this spiral like wire is called tungsten. Got it? And this is to be, the bulb is filled with the gas called either nitrogen or argon. They are chemically inactive. They give long life to the bulb. When the electric current flows in this electric bulb, see, it flows through the copper wire, then it will reach the tungsten. And an important characteristic of tungsten is it has high electric resistance. If large amount of heat is produced, heat has to be produced, then obviously its resistance should be more. Got it? Then when it receives the current, it gets heat up to 3880 degrees Celsius. So then it does not melt even at this high temperature, because its melting point is high. Clear? These are the 2 important properties of tungsten. One is it has high electric resistance. Second one is it has high melting point. Clear? Now let me just go for showing you an electric bulb. Observe this. See that it is an electric bulb. It is, you can observe that as a metallic cap, and you can notice that 2 pins will be there. These 2 are terminals, and here these 2 pins for fixing this bulb to the holder. And now you can observe this. Here stud is there, inside that stud is there, which is called support, and 2 copper wires can be seen. And you can also notice that a spiral like wire, that is what we say tungsten. Clear? So this is the information about an electric bulb. Now we will move on to one more electric device. As I said, it protects, it acts as a safety device. When excess amount of electric current flows in the circuit, it breaks the circuit automatically. What is that? It is fuse. Electric fuse. I'll go for writing here. Second one, electric fuse. There are different types of fuses are there. Now, the most commonly used fuse will be shown. Once I tell you the definition of electric fuse. A safety device which breaks the circuit automatically when excess amount of electric current flows through it is called electric fuse. It is also one of the device which works on heating effect of electric current. Then in that fuse there will be a wire that may be made of either iron, copper, aluminium or an alloy of tin and lead. But in most of the fuses we go for using the alloy as a filament. Then what are its important characteristics? Even it has some important characteristics, that is one is it has low melting point. When excess amount of current flows, it breaks the circuit immediately. I'll go for giving you more information. Observe, this is fuse. It is fuse, and this is covered with a ceramic box. Here also a box like structure is there. Ceramic, it is an insulator. This is called holder. Now you can observe that this is fuse. Here two terminals are there and these two are to be connected with a wire. Here I have used copper wire. In place of this copper wire we may go for using either iron or aluminium, but most commonly used is an alloy of tin and lead. See that, and it is to be fixed in the board, and this part is to be fixed like this. Now let me go for drawing the figure of this fuse. Just go through these two electrical components which work on heating effect of electric current. I have already explained both of them, and I have given the information also. You have to copy these points. Before that, just go through these points one by one. An electric bulb, it is a device which converts electrical energy into heat energy, then light energy. Even the question can be asked like this. Write the energy conversion that takes place in an electric bulb. You have to write electrical energy into heat energy, then light energy. Okay. And I have already told you, it works on heating effect of electric current. What is the filament used? It is tungsten. What are the important properties of tungsten? It has high resistivity, nothing but high electric resistance. And second one is, it has high melting point, that is about 3880 degrees Celsius. When electric current flows through an electric bulb, then the filament in it gets heat up to a temperature of about more than 1500 degrees Celsius. Then it produces the light. And another important thing is, whatever the amount of electric current flowing in the electric bulb, maximum power consumption takes place to convert electrical energy into heat energy. Only the little part of the remaining current is used for converting that into light energy. Next, we know that it is filled with chemically inactive gases. What are those? They are, one is nitrogen and second one is argon, to give a prolong the life of the filament. Next, observe second one, electric fuse. It is also an electrical component and it acts as a safety device which breaks the circuit when excess amount of electric current flows through it. Got it? And I have written the definition. Even this will also work on heating effect of electric current. Then it is always connected in series with live wire, because the main supply of current is along the live wire. That is why fuse will always be connected in series with live wire. And it consists of a filament. that is an alloy which is made of tin and lead. This is common alloy used. Other than this, we will also go for using either iron or copper or aluminum. Then fuses used for domestic purpose, it is rated as 1 amps, 2 amps, 3 amps, 5 amps, 10 amps, 15 amps, like that. It continues based on the amount, required amount of current. Then you all may be thinking that, let me give you just a small information. Last year only you had got information about power. There you had used the formula P is equal to W by T, P is equal to E by T, likewise P is equal to V into I, right? Now I is equal to P by V. Whatever the electrical components that we are going to use, they are to be connected with a potential difference of 220 volts. It is common all over India. The required amount of current for, according to your need, assume that it is just about 1 kilowatt or nothing but 1000. See here, 1000 watt divided by 220. 0, 0 get cancelled. Then this is 50 by 11. Can be written as 11 4s are 44, 6 will remain, it becomes 60. Then 11 5s are 55, 5 will remain 50. Then 11 4s are 4.54 amps. So this much rating fuse is required. Did you understand? If around 5000 watt of electric power is required, then what should be the rate of the fuse? Then just divide this by 220, 0, 0 get cancelled, then this is 250 by 11, start dividing 250 by 11, 11 2s are 22, then 3 will remain, it becomes 30, now 11 again 2s are 22, then 8 will remain, it becomes 80, 11 7s are, so 22.7. That means approximately we need of 25 amp. We need of an electric fuse whose rating is about 25 amps. According to the requirement, we will go for using different fuses, different rating fuses in the electric circuit. And please go through this figure. I have already shown you how will be the fuse, the common fuse will be, which is used. And here, whatever the ceramic box I had shown, this is the fuse holder. It is the fuse holder. I have drawn that. I have shaded with black. Next, another part. This is actually fuse. Actual fuse will be like this. Now, observe. Here, this is whatever this part is there, it is called fuse grip, and these are the terminals where we connect the filament. And in the fuse holder only, there will be two terminals there, two live wires will be there, and this is the way we will go for connecting fuse in the circuit. Got it? Dear students, now I have given you the information about both electric bulb and electric fuse. You have to pause the video and should copy it from here to here. Yes, go for copy. Okay. Dear students, I hope that you might have copied. Now we are moving to the next part of this chapter. In next part, do you know what we are going to learn? Yes, we are going to learn a concept, that is the consumption, electrical current consumption by the electrical components. It is what we say the electric power, which you have already learnt in your previous class, that is in 9th standard. You have defined the power as the rate of doing work. Similarly, electric power, the rate at which electricity consumed by the electrical component is called electric power. Let us get more information about electric power in tomorrow's class. Okay. So before concluding the class, let me remind you one thing. Dear students, whatever we have covered today, please work out them without fail today itself. And today we have covered three important concepts. One is heating effect of electric current, that is we have derived the formula to find out the heat generated. Second thing is we have solved some problems on the formula H is equal to I square into R into T. And third point is some of the practical applications of heating effect of electric current. Got it? So with this, let us stop the class. Thank you.